Okay, so here we're going to do some limits. We're doing graphical limits, and then I'll also do an example of the problems with the table as well. You guys are going to be really good at this, which is great because this sort of underpins all of calculus. So having a good understanding of this is really fundamental to the things that we'll study later in your math career. So let's pay attention to what the question is asking us. So the little minus here, it's a little hard to see in the video, I bet, but there's a little minus here. This means the left limit, so the limit as we approach from the left. The plus means the right limit, so the limit we approach from the right. The plain old one means the two-sided limit. So we'll see what that looks like here in a second. And then f of 1, you already know what that means. That just means the value of the function. Okay, so from the graph here, we want to walk towards 1. So here is x equals 1 right here. I'm going to make a little mark there because we're going to be dealing with that. I'm going to walk towards 1 along f from the left. So imagine you're starting somewhere to the left of 1, somewhere over here, and you're walking this way. We want to look at the y value we end up at, and that y value is obviously 4. And then from the right, my right limit, looks like we end up at the same spot, right? So 4. Because these two are the same, so because these two things are the same, we say the two-sided limit is also 4. And then notice there's a hole at 4 right there. So the value of f, we'd say, is undefined. And we'll take a look at one more example of these graphs ones. I want to do one now where the limit, the two-sided limit, does not exist. Okay, so here we have a left limit. We're looking at x as it approaches -2. That's here, right? So notice this one looks a little different at that point. So -2 from the left, well, we're going to go to the left of -2, walk towards it. The y we tend towards, we look to be ending up at, is 4. From the right, now we end up somewhere different. So this y is 1. Now, here, the two-sided limit does not exist. So one of our conclusions is that when the left and the right limit are not equal, that two-sided limit does not exist. And that's what we have here. This is not equal to this. Okay? So it doesn't make sense to talk about the overall limit of the function because we end up at two different spots depending on which side we're starting on. Right? F of -2, though, in this example, does exist because we have a filled-in circle here. So that would be 1. So notice open circle, it's not 4. 1 is the value of the function. So we'll move on to a table example. These are pretty fun, I think. So what they give you here, I love the way they designed this. What they give you is like a calculator. You pick x's, and then it will spit out essentially the y values for you. So we're using the same reasoning we use in the graphs, except for here we have this like calculator thing instead of a graph of it. We want to figure out the same result. So what I want to do, we'll go from left to right. I want to approach 2 from the left, which means I'm going to type in values that are a little bit less than 2. So not negative, just positive. So 1.9 is a little bit less than 2. We'll click try. Notice I get -3.1. Okay. How about 1.99? So that's a little bit less than 2, but closer than 2. Okay, 3.01. We'll do one more. 3.001. So it looks to me that the limit is approaching -3. Now, we're going to do the same thing for the right limit, but we want values that are a little bit bigger than 2. Okay, so 2.1, 2.01, 2.001. It looks to be that they're approaching the same thing though, right? Yep, -3. And because these two are the same, we say the two-side limit is also -3. Then the last thing is, what is f of 2? Well, that means we just plug in plain old 2 and see if it spits something out for us. Interesting. So f of 2 is actually -4. Okay, so that's an interesting result. So we have, as we're walking towards 2 along our graph, we get closer and closer to -3. but then the actual result that we get when we plug into is -4. So let me draw what that would look like for you. So what that is, right, is here's my function getting closer to 2 on either side, and then we have a hole at 2, and it is defined down here at -4. Okay, so you could have gotten a graph one that looks just like this. This is what that would look like as a table, right? So here is like -3 right here is my limit, and then here is -4 is actually what my function is defined as.